Good day, geometry. We are back for another year of videos and binders and objectives. We're going to start by defining geometry, and I've only got a one-liner here to define it, which means it's a pretty simplistic definition, but it includes a lot of stuff. And the definition for geometry is really the study of no. The study of relationships. When you are done with this class, you will all be relationship experts. That's a guarantee. Whatever kind you want. The study of relationships. Because, I mean, and shapes is part of that. What do other people say? It's basically the relationships that things have with each other. Normally in shapes, we're talking about geometry, but also when I teach you how to argue, right? Relationships between things. So the elements of geometry, the things that you'll be seeing again and again, the first and most basic is a point. And a point is a location in space. Not the space, the outer space, but just space, okay? And a point is notated with a dot and a capital letter. Labeling, you will come to find, is extremely important in geometry because you can describe things with words. You can also describe them with labels, okay? And labeling, sometimes you use capital letters, sometimes you use lowercase. It's really important to pay attention to how something is labeled. So it's a location in space and point A. A line is a, let's see how I'm going to word this. It connects two or more points, okay? And in geometry, lines are always straight. They cannot curve. And they never end. Lines are always straight and they never end. Okay? You think of a number line, right? The reason why it's a line is because it goes on forever in both directions. The lines on a coordinate plane, a linear function, is a line. They are straight. We put arrows on each end because it goes on forever. So how you can notate a line, you must have at least 2 points to make a line. That's why in algebra we have the y-intercept, and then we use the slope to find a second point. You must have at least 2 points to connect. And how you would label this, you could either label it line AB, so A and then B with a little line over the top, arrows on each end. You could label it line BA, so put B first and then A, basically saying that this travels from point B to point A. It's a way to get from point A to point B or point B to point A. Or you can label the line itself with a lowercase letter, kind of near one of the arrows. And you could call this line R. Right? So 3 ways to identify that. Line AB, line BA, or line R. Notice the use of a lowercase versus capital. A capital letter is for a point. A lowercase letter is for the line itself, the whole thing. Have I lost anyone yet? Anyone want to go back to algebra? Yes, Kylie. So parabolas aren't a line, okay? Parabolas are a type of graph that describe how something goes up and comes back down, or goes down and comes back up. But anything that doesn't have slope is not a line, okay? In algebra, I probably said connect your points with a line, right? I probably did say it, but in the geometric sense, it's not a line. Any other questions or questions, comments, concerns, complaints, challenges? That could be a new one. You challenge something I say. Criticisms, congratulations, they're out there. A plane exists. Yes. Let's keep our questions on the topic of geometry. You can save that for when we're not recording. Because remember, anything that's on a recording can be played back at conferences. How's my kid doing? He really likes to know about the baking soda when I'm teaching about geometric terms. It's fine. Exists when there are 3 or more points that are not collinear. Yeah, not collinear. What do you say? You haven't. Have some faith. Like I said, there's a lot of new terms here. I wasn't lying. I wasn't just saying that to say stuff. So before we draw the diagram here, a plane exists when there are 3 or more points that are not collinear. The very next definition is collinear. What does it mean if points are collinear? If you just had a guess, take a look at the word. Maybe go back to your Greek and Latin. Collinear. What would you guess the word collinear means? Yes. Okay. Collinear are points on the same line. You'll actually find that geometry brings back a lot of that Greek Latin stuff from last year. If you don't know what a word means, you can oftentimes kind of figure it out by looking at its pieces. Okay? So a plane exists when there are 3 or more points that are not on the same line. So if we have points A, B, remember, I can make a line with any 2 points, but if I had a point C, I can't make a single line containing all 3 points. They're not collinear. So a plane is just kind of like a space around it. Think of it like a tabletop or a floor or a wall. Okay? These 3 circles here would be part of this plane. They're non-collinear. Okay? Alex? No, it does not have to be. It usually is a rectangular shape, but it really doesn't have any shape to it. A plane doesn't really have dimensions. It's just the space that contains the points, basically. Okay? Generally drawn in a rectangular form, but doesn't have to be. And how you would label this, you would label it plane ABC, or plane BCA, or plane CBA. Basically, a plane and then the points that it contains. It's the plane and then the points that it contains. Like a line, you can also use a letter for this. This one you might sometimes see capitalized, but it's not going to have a dot next to it. So it doesn't, you know it's not a point. So it'll be down in the corner or up in the corner. It won't have a dot. So you can also call this plane M. Okay, plane M. And now that we've talked about collinear and planes, you can probably guess what coplanar means. Damien, your time to shine? No. You'll have another time to shine later on. Joey? Yes, points in the same plane. You did? My bad. My old ears misheard you. Aiden.
Why does collinear have 2 lines?
2 L's?
There are 2 L's.
2 L's? I did not invent spelling. I don't know. I have no idea. It just does. Okay? Questions so far? All right. Some other elements of geometry. Segment, ray, and intersection. You've probably heard of a segment and array before. What is a segment? Kylie? Okay. So it is I'm going to call it a line, but it's not a line because it ends. Yes, it's a line with a beginning and an end. So it's not a line. It's a line in quotations because it is straight. Okay, it does not curve. It connects two or more points. But the important difference is that it has a beginning and an end. So if we had points A and B, okay, and connected them without the arrows, that would be segment AB. And another important difference between a segment and a line is that a segment can be measured. A segment has a length because it has a beginning and an end. A line cannot be measured. It goes on forever. Okay? So when we talk about segment length, okay, where it can actually be measured. And how you would notate this, you could use AB with a segment symbol over it, no arrows. Or you could do segment BA, again, no arrows. Even when you do have a line, if you had points CD, okay, if we did want to measure the distance between C and D, we could ask for the measure of segment CD, right? CD are part of a line, but if we only want this section from C to D, we can say that is a segment because we're starting at point C and ending at point D. So if you really want to annoy a future teacher, next time that one of your homeroom teachers says, line up for mass, actually you can say, you mean segment up for mass because it has a beginning. Okay, no, because that is a difference.
I think you should say that's
Okay, yeah. All right, segments. What's a ray? What is a ray? Yes.
Is it a line with the beginning but no end?
Okay, so it's another quote-unquote line. It's not a line, but it has some similar properties. A line with a beginning but goes on forever. It's kind of tough to think about a contextual real-life ray, but yeah, your time to shine. Oh, for the next one? Okay. What would be a ray that you can think of? Something that has a beginning but then theoretically goes on forever.
A line.
No, a line.
Because like a line, it has to start at some number. Because it has to start at some.
A line does not. A true line goes on forever in both directions. A ray starts at a number and goes on forever. But what's like a real life example of a ray? Yeah.
The universe.
In what sense?
That it started with the Big Bang and then it keeps going on.
So time? Are you saying? Because if it so that's where science and faith kind of collide a little bit, right? Because the science, some say that the universe has a beginning, okay, which it has to have a beginning, but then our faith comes and says that, God has always been and has the universe always existed, like is there beginning to time? So we're going to stay away from that a little bit unless I can get Boyle in here so I don't say something stupid. But in the universe, what about the sun, right? In theory, all right, light continues to shine. It goes on. It has a starting point, and then it continues out. Okay. What's that? Thanks for being a Debbie Downer here, Alex. The sun will explode. Okay. But what a ray looks like is we'll use A and B again. Okay, a ray begins at point A and continues through point B. And when you notate a ray, it's important to notate which letter or which point it starts at and which point it continues through. So you'd notate this with AB with no arrow above the A, because that's where it starts, and an arrow above the B, because that's where it continues through. You could also technically write it BA with, again, no arrow above the A, because that's where it starts, and an arrow above the B, because that's what it continues through. However, this would be the most correct way to write it, because that's the direction the ray points. But if you had a ray that was going like up and down vertically, then either way would be correct here, because it doesn't have a horizontal movement. But in this case, the left one would be most correct, because it shows the direction that the ray points. You also have segment AB here, right? If you want to think about just that distance, segment AB is present as well. Alex, you've been waiting patiently. Thank you. What about pi? That would be like a ray in decimal form. Sure. It's got to be beginning and continues on. Well done, Alex. I'm glad you kept your hand up and waited for me to call on you. That was a good example. Yeah. Yeah. Oh, intersection. Go ahead. Your time to shine. Take 3.
It's a line with no beginning, but it has a. Buddy, what? So it's weird line. Something to end it.
So close. Claire. Yes. An intersection is the points where segments, rays, lines cross. The point where segments, rays, lines cross. In the future, yes. In the future, to abbreviate, I'm going to say this segment, rays, lines as SRL, just to keep definitions a little bit shorter. So just know that when I write SRL, I'll verbally say it, but just so you know, it means segments, rays, lines. But it's a point where segments, rays, lines cross or intersect. You think about intersection on the roads where two roads cross, intersect, right? Okay, so point A there would be the point of intersection of those two segments, rays, lines. Draw the diagram being described. It says, well, first of all, what does that say? Someone read that for me with no, yeah, Jack.
It means it's J and N, and then there's a line above it that has 2 arrows.
Okay.
Then it intersects.
Shh. Let the man talk. Go ahead.
With CP,
Mhm.
with another line, a capital whatever top thing, at point A.
Okay, so these two things above our J, N, and CP are different. One does have arrows, like you said. The other one doesn't. What does that mean? Because they're not both lines, right?
Oh, I understand now.
Yeah, Jack.
So the first one is a line.
Yep.
And the second one is segment.
Segment, okay? So we have line JN intersecting segment CP at point A. So you can draw this a number of different ways. Start with a line labeled JN. Your line does not have to be going that same direction. It could be vertical, it could be horizontal, it could be diagonal the other way, okay? It must be straight though, right? And CP, segment CP, and again, doesn't really matter direction here. Doesn't matter if C is the top point or the bottom point. Doesn't make a difference. But those two things intersect, line JN and segment CP. And they intersect at point A. So that is one of an infinite of examples that would describe line JN intersecting the segment CP at point A. Someone read the next one for me in words. Sophie. Ray BC and ray BD in the shape of an L. Okay. Who wants to come up and draw what they think this is going to look like. All right, Beckman, I'm not called on you yet. Damien will have plenty of opportunities. You know what? I no doubt that you would have.
Stop making fun of me.
Job well done. Okay. Ray BC and Ray BD in the shape of an L. Point B must be in the middle because both rays begin at that point. This could be D, that could be C. That part is interchangeable, but point B has got to be in the middle, and it needs to be in the shape of an L. Questions so far? Yes, sir. What's that? Oh, the bottom is a new symbol. It says, keep calm and do your homework. This is where I give you a book assignment. That's weird. Usually I get cheers when I say that. Why? That's really odd. Your assignment from your textbook. Yeah, I told you we'd be using this. You don't need it today. You have a minute left. You don't need it today. Oh, let's see here. I'm thinking. Hold on. Let's go with. Just to ease you into this, on page 5, you are to do 3 through 6, and then 8 through 11. Okay? Now, this homework, folks, this homework can be done on the back side of CO1, so you can keep it all in your binder together. If you want to do it on a notebook piece of paper, you can do that. Okay? It's up to you. But this is what I'll be checking in for tomorrow. The man raises a solid point. You remember my outro. That's how you math. I appreciate the